how a lot of this stuff that we look at starting today is review of a bunch of stuff throughout the whole semester. Excuse me. So when we're dealing with combination areas, very similar to when we had the, what do you call it, where we had triangles inside of a square, things like that, we kind of look at it along the same lines. What's the large shape? What's the small shape? So how was the shaded area created? Well, an example like this is really easy. It's a big circle, subtract out the center. So it's just a matter of finding the two separate areas and subtraction. Now, when you're dealing with circles, those are one of the easier things to have to worry about because it's just pressing buttons for squaring and throwing pi next to it. So the large shape, and I want you guys to get in the habit of writing down what you're about to do before you do it because it does help. So this one's just the area of a large circle, subtract the area of a small circle. Well, what's the radius of the large circle?
4.
4. The radius of the large circle is 4. So if the radius of the large circle is 4, it's 4 squared pi. What's the radius of the small circle? 2. 2 squared pi. What's 4 squared? 2 squared. When you're dealing with combining like terms, treat pi as you would a regular old variable. I can combine these two because they both have pi in it. What's 16 minus 4?
12.
There's your answer. Yes, sir.
Is that an L? What's the A?
This one? Yeah, I wrote down in shorthand what area of the large circle, subtract the area of the small circle. There, large, small. Okay? So, really, all this is doing basically 2 area problems in one. Sometimes there's 3 area problems in one. Okay? It's nothing out of the extraordinary. Okay? I'm making up words, that's why I have a degree in math. Okay? Pi, this is exact answer. If I wanted it in decimal form, what would you press in the calculator? The little 2 arrows to give you a decimal and you go on from that. Okay?
They're more like triangles.
What's that? Oh. What's that, Lil?
No.
I said they're more like triangles.
I have a question. You know how you said arrows? I said
Yeah.
they're kind of more like triangles.
I just said that. I know, I told him. That's
Good conversation. Yes,
I
ma'am.
told him already.
I'm gonna wait. I thought that you were gonna
What?
that was, yeah, I had a question about that.
Okay.
Would you just
For I'm.
Well, I see where you're going with. Oops. I see where you're going with that. Disregard the vertical extra line there. If you squint, it goes away because it's really not there. If you start thinking about this again, you would have a large shape and a small shape. What's the large shape? I know this is tough for high school. What is the smaller shape? Okay, so the area that's shaded was created via area of a square. Subtract the area of a circle. Bless you. So, like I said, a lot of this stuff starts out kind of easy, and I'll hit you with the hard, the complicated here in a little bit. How do you find the area of a square? Base times height, or in this case, since it's a square, it's the same thing, so you just square it. Yes, sir.
So are the quadrants of the circle the tangents?
Oh, you mean these points here?
Yeah.
Yeah. So you get 100 for the square. You okay with that? I don't have to write that down. Now, what is the 10 also representing from the square in terms of the circle? The diameter. So if your diameter is 10, what's the radius?
5.
5. So then the area of the circle would just be subtract the 5 squared pi, otherwise known as 100 minus 25 pi something squared. This would be an exact answer. If I asked for an exact answer, you'd leave your answers in terms of pi, or with a square root if you had to, or something along those lines. If I asked for decimal, rounding to the nearest hundredth, 2 decimal places, you would then just type this in and press enter, and you get
I gotta stop.
29-ish, 30-ish.
21.46. Yeah, 46.
467 would be 47.
No, 46.
Wait, I have a question.
Yes, ma'am. How to get what?
21.46.
I typed that in my calculator.
So wait, you just took out the something squared and just typed in 10 minus 25?
Pi.
Okay, I was just making
Yeah,
sure.
no, it is quite literally
If we're done,
100. It's quite literally type it just like that.
okay,
There it is.
makes sense.
Okay. Remember, when you put pi next to a number in a calculator, it automatically implies that you're multiplying it by pi. All right. It automatically does that for you. Okay. Like I said, this isn't really goofy.
My pictures is nice
What?
today.
What are you talking about? Mine's perfect.
Mine is more perfect. That's a perfect.
Now, as you get into this, you're going to have to start doing multiple steps. And that's kind of where a lot of the stuff leads to. As we get into more and more of our area stuff, you have to do more than one step to be able to figure out the area of one of the objects. So this one, you have a circle, and inside the circle there is a square cut out of it. Now, the circle has a radius, has a diameter of 16, which means it has a radius of what? 8, good. So we start with that. We know that we have a radius of 8, so I start filling in blanks. I have the area of a circle, I have to subtract the area of a square. Well, this is a pi r squared, so it's just 8 squared pi, so it's a 64 pi.
You always use the radius, right?
See, okay, so you know, like it's a square and it's like, cut it in half, but like.
I know where you're going. I think I know where you're going with this.
Would you use
What
that when you just like? cut
you
it?
could, but more importantly, when you have a square, the diagonal creates the 45, 45, 90. So you have to remember the ratio of the sides. 45, 45, 90 is what we call a right isosceles triangle. We talked about this a ton back in the end of January in chapter 7. And we talked about the ratios of the sides. The ratios of the sides always had the same pattern when you're dealt with this special right triangle. It was x, x, and then x times the square root of 2. That was the ratio of the sides for the 45, 45, 90. That never goes away. You're going to see that time and time again throughout the rest of chapter 11 and into chapter 12. Also, I'll write down the 30-60s here as well in a second because it's one of those things that shows up. So if we know that across from the 90 is 16, remember, all we did was set up this very quick single-step algebra problem. We wrote up x root 2 equals 16, which means all I had to divide both sides by the root 2. Now, when you did that in your calculator, what was great is that it rationalized your denominators for you. It did that automatically. And it spit out the value of x to equal 8 root 2, which means the side lengths were 8 root 2. So you're back to the idea of the 45, 45, 90. You have side lengths now inside the square of 8 root 2. So you have to find the area of that square. And here's where you have to be very careful. Notice that I wrote it up as the quantity 8 root 2 squared. If you don't put parentheses around that whole thing before you square it, you're going to get the wrong answer. Let me show you what happens. If I just type in the calculator 8 root 2 and I square it, well, not 8 root 22. Really screwed this up, sorry. If I press the right buttons. There. If I type it like that, I get 16. But if I do it the right way, I get 128. Because if you don't put parentheses around it, what the calculator does is it squares the last thing that's there. So the square root of 2 squared is 2. 2 times 8 is 16. That's why I was doing that. But yet if you put it in junk squared terms, you get 8 root 2 times 8 root 2. So that's why you multiply 8 times 8, root 2 root 2, and it spits out the 128. Okay. So anytime you ever have to square anything that has radicals with it, please, 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 make sure you throw it in parentheses. Okay. Otherwise you're gonna be wrong. Don't be wrong. You got it. It sounded like it, didn't it?
Yeah, you have to show us your phone.
I don't know what you're talking about.
You're pro.
It's Murphy. Yeah, just
Ow!
that.
It's been like a whole year.
So the exact answers would be 64 pi minus 128. But yet if I ask for the rounded out decimal, I just type it in the calculator and press enter.
Only if you ask for it.
Yeah, it'll say, and I'll either say give me the exact answer, or I'll say give me rounded to the nearest hundredth. And I'm trying to show you both ways today, just so you guys get in the habit of seeing it. So it's 73. Okay. And all you're doing is just calculate work. Okay. So it really isn't all that difficult. But what's happening is that you have just 2 area problems built into one. Okay. But do they get goofier?
Yes.
Of course they do. Why wouldn't they? It's more fun that way. Where was the one? So, for example, I want to find the area of the shaded region. Now, before you get too crazy about that, once you really just stop and look at what exactly the area is, the area is just this part. It's that part surrounded by that's all that is.
Oh my gosh.
What you just did.
Broke it down.
Hello again.
Hi. How are you?
I'm great. How you been? Their baseball cards are pretty awesome.
He just broke it down.
I think that's cool. So basically what you're looking at here, do the outer parts of the circle even matter? No. Do I have to count 2 circles here? No.
It kind of looked like you glitched for a minute, because like you had got the pass, and you came in and you was like you got, it was so funny. Did y'all see it too, or am I just okay?
Anyway, so all I gotta do is take the square and subtract the circle. Alright?
the same thing we've been doing.
Yeah. It's just that sometimes the diagrams look weird. The sides of the square are 6. So what's the area? 36. The diameter of the circle is 6. What's its radius? What's its area? 9 pi. That would be my exact answer with, this case it's meters squared. But yet, if I press the buttons on the calculator, it'd be 36 minus a little bit more than 27, so it's 8-ish.
Question?
7 point.
7.70.
That was close. Yes, ma'am.
How did you get the area of the circle?
Okay. I got the area of the circle. The diameter is 6. It gives me a radius of 3.
And Mr. Murphy, we have an error.
3 squared.
It's 7.73.
779?
7.7.
That's 9.7.
Is it 202 Luna then?
7.7.
Yeah.
Yeah.
Bless you.
242.
I thought it was
You mean
773. 202.
Bless you.
Thank you.
Sorry, I didn't mean to say that to everybody because now everybody's going to argue about the whole Luna versus Empire. 590, 580, 300 Empire.
There's another one.
So we talked about that. This, not that we ever get off topic, but
We
God.
got you covered. Chicago.
there are in advertising. That's what they try to do. They try to get something to stick in your brain that you'll never forget, and obviously, it works.
That's for math.
We all need some department.
See, how do I remember that? Like, I haven't seen the commercial before.
Because it's on every single local Chicago channel. It's always on.
AG, work, work. 877 cash now.
Money is needed.
Yeah, the windows down.
Oh, that's great. Oh, I didn't even think of that one. All right. So, that's good. That's good. Now, this one, as we said, things start to get a little bit goofier as you get into these things. Now, what's the large shape?
Trapezoid.
It's a trapezoid, okay? It's a trapezoid. What's cut out of it?
A half a circle.
Half a circle. What do we call a half a circle? So what do you think the area of a semicircle would be? Half of pi r squared. Okay. So one of the things that wasn't marked on here is that middle segment of the trapezoid, see how it's parallel to the other two? And it connects, one side is a bisector. The other, yeah. That's one way to get to what the length of that is, but we don't need to know what the length of that mid segment is. But what they did forget to mark in order for this to be true is this. That way we know that it is congruent on both sides, which gives you a radius of what for the circle? 4. Okay. So take the area of a trapezoid, 1/2 the height. Oh, I forgot to write it out. Area of a trapezoid. We're going to subtract half the area of a circle. Okay. The area of the trapezoid is 1/2 the height of 8 times the sum of the bases, which were 20 and 16, otherwise known as 36. Is it okay if I just put those together right away?
Yeah, that's fine.
Then to that I have to subtract half of pi r squared. Okay. What's half of 8?
4.
All right, 4. So double 36, what do you get? Double that, what do you get? So 4 times 36 is 144.
And you just know this.
What? Double 36.
72.
Double that.
Oh.
And that's all, because when you multiply by 4, you're doubling something twice. That's all.
I was
Okay.
like, in my head, I'm like.
Now, for the area of the circle part, you have to think about your order of operations. Order of operations tells you to take care of what first? Parentheses. What's inside my parentheses?
4 squared.
Which is?
16.
What's half of it? 8. So my answer would be 144 minus 8 pi. This would be in terms of an exact answer, square inches. But yet if I wanted to find the decimal equivalent, I just type it in the calculator and you get 130-ish. I don't know.
418.
I was nowhere close.
118.8 or 87.
Okay. Can you get somewhere around there? Could I just make 3 lefts? Would that be right?
3 left.
Yes, sir.
So, you were only supposed to cut the 8 in half, right? Not
Right.
6.
Yep. Because that's only on that side. Well, I did this side already because I did. Doesn't matter. The order when you multiply doesn't matter. 2 times 3 times 4 is the same thing as 4 times 3 times 2. 2 times 4 times 3. It all works. What I did was just mental math because I didn't have a calculator on me, but I knew half of 4 was, or half of 8 was 4, and if I double something twice, it's the same thing as multiplying. We just did mental. So, like I'm saying here, guys, a lot of this stuff really isn't all that bad.
It's just remembering the.
Yeah, it's just a matter of using a couple of different formulas. Okay. So let me show you the. Okay. Now what do we have? And what do you have to cut out? How many? 4. So you have a square, and you have to cut out 4 circles. So you write it out. You have an area of a square. Subtract 4 times the area of a circle.
So what is it?
And we know that all 4 of the circles have to be the same because notice all the radii are the same.
So 12, so each one is 5.
Correct. Very
Yeah.
good. Very good. So we just started out by looking at the problem that they give you. Well, 20 by 20 is easy. It's 400. Side squared. Side length times width, base times height, whatever you want to do. So you have 20 squared, gives you a 400. To subtract that, now since if you think, the 20 goes through both of them, which means half would be 10 and 10, which would be the diameters of both all the circles. Have diameters of 10, which give you radii of 5. Okay. So then you would subtract out 4 of 5 squared. Well, what's 5 squared? How much?
I heard 300.
I thought you said 500.
I said 25.
Oh, I swear, I'm sorry. I
heard-
swear I thought you said 500.
I heard
That's why I was
that
like,
too.
wait.
I heard 300.
So, all right, what's
Yeah, I was so scared. 25.
what's 25 times 4?
100.
I was gonna say.
And there's your exact answer. All right? So, I'm trying to get you guys to understand that as goofy as some of these things may look, the math isn't hard. It's just a matter of keeping things straight as far as what shapes you're working with and what you're setting up. Okay? Wait, what? Bless you.
How'd you guys? Oh, you just brought it down to 4.
What do you mean?
So like for the equation, I didn't see you brought it down.
Yeah, because there's 4 of the circles.
All right.
Instead of writing 400 minus 5 squared pi minus 5 squared pi minus, I just 4 times it. It's 4.
You know what I need next?
We'll get to it. This one's a little bit weirder because you have to actually think about what information are you given. Yes, you're given a circle. Congratulations.
With 4 slices apiece. With 4 slices. 2 different
A
angles.
deep dish.
72.
With 2 triangles. That's how they cut deep dishes.
Each one is 72.
Yeah.
No, they don't.
Yeah, they do.
That's a 9.
You can cut them into fours.
It's 109.
Yeah, I know,
one
one
versus
versus
109
109
is 218. It's 218 minus 142.
It's 71,
There you go.
not 2.
Now you did this the long way. Now what I want you guys to think of here is that this is a problem that you've actually done before. If you get rid, yeah, exactly. Instead of working with the circle, we all know that vertical angles exist when two lines intersect. Well, the two lines that intersect here go through the center, which means they're both diameters. Which means if this side is 109, this side has to be 71. This one is 71, and this one is 109. Now, if we're trying to find the area of the shaded region, wouldn't both of these areas be the same?
Yes.
And aren't both of those regions just one giant sector then?
Yes.
Well, if that's an area of a sector, because that's really all this is, the area of a sector is your angle over 360 times the area of your circle. Well, how much of that circle is yellow? 142 degrees. And we got that just by adding those two spots together. So we just do 142 over 360 times 5.2 squared and slap a pi next to it.
How'd you get 142?
71 and 71. So this is absolutely really nothing like you, or nothing all that new, really. You're just putting two parts together of common stuff that we looked at. Okay?
Okay.
Whatever decimal that is, I'm not sure off the top of my head, but it'll just be some funky decimal. All right, so you're getting worried about this one, number 30 you were saying?
What the heck? No.
That's bad. Let me see what's better.
Let's throw some darts.
That's on Friday.
For real?
Yeah,
We get to throw darts?
maybe.
And restrict
This
it.
is a target, if you will. How many of the circles are shaded?
Two.
Two of them. So we basically have to do here is we have to find the area of two shaded circles. Now, yes, sir.
Wouldn't this probably be like the one we did with the circle and the circle inside of it?
Yes, exactly right. You just do that twice. So think of it this way. You're going to find the area of the large circle, subtract out the area of the rest. And then to that, we'll add the area of the next, the other yellow circle, subtract out the smaller rest. Here's what I mean. Each one of those chunks is 2, which gives you a radius going all the way out of how much? Who do you appreciate?
Good one.
Bars. Bars.
Sorry. So if my radius going out is 8, what's the area?
8 pi. No, 64 pi.
64 pi, good. So if it's 64 pi for the entire circle out, I need to subtract that much, which has a radius of 6.
36
So I subtract out 36.
Wait, why do you
What's that?
why do you do
Think of this as the donut hole problem. We had the big circle, subtract out the hole in the middle. That's all I'm doing. Because what I'm doing, I'm going to account for,
that? Subtract the one that's not shaded?
yes, I'm just going to account for this outer ring. So if I take just the whole thing, subtract out this middle part, I'm left with just the outer ring. That's all I'm looking at here. Okay? So what's 64 minus 36?
28.
So the outer ring then, the outer ring has an area of 28 pi somethings, okay? Wait, what? Each one of those chunks is 2. 2, 4, 6, 8. 8 squared is?
Alright, yeah, I got you.
Do the same thing with the inner circle.
2, 4.
This has a radius of 4. Radius of 4 is how much? Squared is how much?
16.
So the other one will be 16 pi. And subtract out the 2, which gives you an area of. So this one is 12 pi. So what's the total area of the stuff in yellow? 40 pi.
That's a lot of pi.
They have a lot of them.
Why is it? What's 12 and 28? Add it together. That's it. That's all that is. You're just finding the two areas independently of one another and just adding them together. Think of this as a problem that looks like this. When you see these,
Okay, go Mr. Murphy, you.
there was one more. Close the screen up.
I thought there was something else.
So
There wasn't-
when you see stuff, when you have problems like these, if this whole thing had the radius of 8, you're trying to find out what that is. By cutting up the rest of that out. You're just looking at the, in this case, I'm just doing this as the unshaded version, okay? To find the area of that unshaded version, I would take the whole thing, subtract out the shading. Okay? And then I would do the same thing in here, because at this rate, when I get to these two guys, since these two are on the inside of the circle, I don't care about what's around it. I'm just looking for this one, subtract the middle. That's why we do those separately, okay? You'll see lots of these problems coming up here pretty soon when we talk about geometric probability, which where it's at, like on a regular dartboard, each space has different value to it. That's why they do that. Oh, gambling. Let's try this one. It's a noodle. It's a macaroni noodle. All right. Now, so yeah. Now, one of the reasons they show you that 180 is to show that it's half the circle. Okay. So what you've got here is a semicircle with a semicircle cut out of it. Okay? Now, each of those chunks are 17, which means take the large semicircle, so it's the area of the large half circle, subtract the area of the small half circle. Okay? So the large circle has a radius of 17 and 17, which is 34. So it's going to be 1/2 of 34 squared times pi, and then subtract out 1/2 of 17.
Wait, would it be another 17?
When you just do 17, how the square times,
Like,
what's
you know how you
17 square
did,
pi?
like you did that whole thing?
I did the whole thing here. This whole part has a radius then of 34. This one has a radius of 17. And the reason that I took half of it is because I'm only really caring about this part. Oops. Okay? Does that make sense?
Well, like, you like shaded the thing, but it's like 17, should it be a 17 here too?
For right here?
Right there and then
Yeah.
right there.
There should be a 17 here and a 17 here. Yes.
But you only said 17 for like
This smaller circle has a radius of 17. The larger circle would have the radius then of 34. That's where I was getting at. Does that clear that out? And then you start to calculate. I don't know what 34 squared is. I know it ends in a 6. Because 4 times 4 is 16. And I just take half of it. So what do you get? What are you shaking your head for? Oh, don't listen to him then.
Oh, I'm not.
What?
I said I'm not.
What? I tried. So 578 minus 17. Oops. 433.5 pi? Is that what you got? Or people
Since you're
type
the
pi?
teacher and you got it, then yeah.
Well, I've never screwed up before.
Five times.
Let me give you a handful of these.
Right, I feel like he'd be lying about some surprise.
Add these to the homework you had from last night. Just use this as your diagrams. Don't do the work on here. Do the work on a separate sheet because you need the space. I mean, you're not doing all of these, so I'll give you five in a second.
This is fine. Yeah, it's always the side.
That's fair.
That's how it's right now. It's like literally split up. Sometimes it goes like this. Yeah, yeah. And it's like.
Maybe you want to forward that to him to that.
It says do the scrap.
Yes, they accidentally sent it. I don't know how you got it. Thank you. I don't know what to tell you. I wouldn't worry about it and not pay attention to your reading. And then do it. You just tell them.
No.
Yeah.
I will next
Yeah.
on that.
Put it a little farther and say, I got this somehow. Don't know why.
I'm told.
Say sorry. I didn't mean to get. I don't know why I got this. You know.
I was like,
And then delete your emails. Don't worry about this. All right. So here's what we got. Did you guys all get one? All right. On this one. Let's do, what's it, 5B? Do those, please. Okay. Let's go 14 through 27. Actually, I'm sorry. Start on 13. Sorry, I forgot I had that. Oh, I know I'm such a jerk. One more. Oh, Murphy, you're so bad. Oh. Nope.
I'm making crepes. And I really don't feel like it.
Yeah, we're making.
You are kind of crazy.
Yeah, you're in my group now.
He's in my group. Why we gotta go all the way to 27? That's like 14 problems.
My table.